My name is Dusty Mabe. I'm a principal software engineer with Red Hat. I work in the CoreOS teams, so at the OS layer of OpenShift. So I work upstream in Fedora CoreOS and then downstream with Red Hat CoreOS, which is part of OpenShift. Today I'm going to talk a little bit about CoreOS layering and give some updates on that effort within Red Hat and OpenShift. So first off, I do want to give a special thanks to a few people who helped make this presentation. So Colin Walters and Zach Zlotnick are in engineering, and they did a lot of the work that I'm going to feature today. And then also Mark Russell, which is our product manager, who essentially talks to a lot of you customers and helps us figure out what we're going to do in the future. Okay, so with OpenShift, we're kind of like on a little bit of a journey. So OpenShift 3 to OpenShift 4 was a major architectural leap. If anybody was with us in the OpenShift 3 days and moved to OpenShift 4, you know it was quite a big change. So we added some things. Opinionated install, right? So now it's very opinionated on what you do. The installer can also do things like provision infrastructure for you, which is really nice. We also added day 2 management. So if you want to manage your configuration on the nodes, you can do that using machine configs. The machine config operator also does things like upgrades for you on your system. We also have the cluster version operator, which keeps everything nicely versioned together. So what was built and tested in CI is essentially what you are going to get on your systems. And then second level operators to handle everything else on the system. So a fully managed, controlled platform. As part of this, we also introduced Rel CoreOS, which you'll hear me slip up and call it Red Hat CoreOS at times. If I do that, you know I'm talking about Rel CoreOS, but I am an engineer, and some of the names sometimes internally are different. But anyway, with Rel CoreOS, it's a appliance-like container-focused version of Rel, essentially. And in this case for OpenShift, we've added OpenShift components into the base OS. So you can't really run OpenShift without Red Hat CoreOS today. It's got everything in there that you need for OpenShift. But this thing, bake the OpenShift components inside. We test it all and build it together with OpenShift. All of the CI happens on top of Red Hat CoreOS. You don't really get one without the other. So they're tested and versioned in concert with each other. And it's also API managed. So for example, that configuration that I mentioned before goes into like a machine config, which just so happens to get stored in etcd, which is kind of what etcd was created for to begin with, right? That's why it's called etcd. Another thing that's pretty cool is you can actually use the OC or the kubectl CLI to like change your kernel arguments for your host OS, right? That's a pretty cool thing to do. We drove the Kubernetes API all the way down to the OS level, right? And then managed that with Kubernetes operators. So this is like, a really nice setup. It's given us a lot of things, a simplified deployment and upgrades, but it's not perfect for everybody, right? So, some use cases, some customers, it's not quite flexible enough. So what are some common requests that we've gotten from customers over time? So one really simple one is, hey, I need this additional Rel package installed. It sounds like an easy ask because, Red Hat already builds that package and ships it for Rel customers. Why can't I have it in OpenShift, right? So that one sounds really easy, but because we essentially ship Red Hat CoreOS as part of OpenShift to every customer, one package that is useful for one customer is not necessarily useful for all customers, and we have to consider that. So we have to say, oh, this is going to increase the size and attack surface of Rel CoreOS. Like, is it worth it adding it for everybody, right? So we've said yes to some things and no to some other things, and like tried to figure out how we solve the problem in the case that we say no. But that's just one example. Security agents is another. So like, in your IT organization, they might require you have certain security agents installed on the nodes that are, any node that's inside of our infrastructure, you have to have this agent. Well, what if that agent's vendor doesn't have like a containerized version, right? That presents a problem for us. Because the goal here is, you run all software in containers, and the Rel CoreOS is essentially like an appliance, right? But it's inflexible. Another one is kernel drivers. So if you need like a third-party kernel driver to actually talk to the hardware on your systems. That's hard to do with Red Hat CoreOS today. I was actually part of a proof of concept a while back to like figure out how we like automate this and build drivers and stuff like that and make it easier. It's just not that easy. So that's another problem. And then, you know, familiarity with the configuration. Machine config objects are like a little bit of a learning curve and a little bit awkward for people to use. They're used to just like editing a file in Etsy and like, why doesn't it work? So that's another complaint that we've had. But, you know, we don't necessarily want to go all the way back to OpenShift 3, right, where customers could kind of just do whatever they wanted to, because that made things like a lot less reliable as far as like when we test an upgrade for Red Hat CoreOS and OpenShift today, we know the path, right? It's a well-trod path. We know what was in the N-1 update and what's in the N because, you know, it's the same for everybody, right? So we don't want to go back to the Wild West, but we do need to make things more flexible, right? So how do we evolve to give customers these things that they need? So to install third-party add-ons, right, kernel modules that you need, to install additional RHEL content, those packages that are requested, and to also simplify configuration management. So to be clear, like if you like the machine config stuff that you are using today, that's going to continue to work, right? If you're on the happy path, stay on the happy path, right? It's going to continue to work. So that machine config API is preserved, but in the new world, there's a new option. And so the new option is CoreOS Layering. You may have heard about it before, but the essential, you know, in a nutshell view of it is it's just a container. The OS update's just a container. You can also modify it like it was another container image, another container base image. So we're not inventing anything new. We're just using the OCI image format, right? Which is really nice because you can actually use all of the tools that already know how to deal with containers to move that container around, do security scanning on it, CI tests on it, or whatever else. So the two things here are, one, put the OS like update information in a container and use that as a transport mechanism, and two, make it really easy to allow people to derive from that container, add things to it, and then push to their own registry. And now that is the source of truth for your cluster, right? So let's dig into an example real quick. So here's an example. I just copied it from the documentation, right? That was easy. So in this example, you have a familiar container file or Docker file. So at the top, we have from, and then quay.io, and essentially a registry location. And you can get that information from your cluster by just running ocadm release info --image for rel CoreOS, and it'll tell you, where the location of that image is for your cluster. So we're doing two things here. We're modifying configuration, and we're also adding a layered package. So in this case, we are adding a configuration file into etc ipsec.d, and we're also installing a package called LibreSwan and enabling the IPsec service, right? So we're doing two of those things that I just mentioned before, which were asked, which is like, hey, how can we configure our systems outside of machine configs? And then also, how can we add an extra package that's already in RHEL? So let's take that to the next step. So what does this look like? What's the workflow look like? So you take this Docker file or container file, you run podman build, or you feed that into your build system, right? People probably aren't manually running podman build a lot. You probably have some sort of integration with a build system. So you build that. It takes the Red Hat CoreOS image that is shipped from OpenShift today, combines that with your Docker file or container file, spits out a custom Red Hat CoreOS image. That gets shipped off to a registry, and then at that point, you have control of what happens after that. So you can do CI testing on it. You can run security scanners on it. You can mirror it out to other registries around the world if you want to. But then at some point, you decide, okay, this image is ready. And you can push it to another registry that's like the final location, but whatever else. As long as you get it in place, then you tell the cluster, hey, I want to use this other image for updates in the future for Red Hat CoreOS. And then it'll go through, it says, okay, I can get to that image. I'm going to pull it down. I'm going to apply it to all the machines in the machine config pool that you add that to, one by one. And it's just like any other OpenShift update. In the future, you build a new image, another image, right? Like a new OpenShift update has come down. You run another podman build, push it through, do CI tests and everything else, and the cluster will update to that image. So that's off-cluster builds using CoreOS Layering. That's available in 4.13 already. So it's already there. You can use it today. But let me talk about something new, which is on-cluster builds. So in this case, it's like off-cluster builds, except you don't own as much, right? So the previous process looks a little heavyweight. We got a bunch of stuff added in there that we didn't necessarily have before for OpenShift updates. So this looks a little bit more like what we have today. So for on-cluster builds, you basically tell the cluster, hey, I like what you're doing, but I want this tweak, right? I want this extra little thing on top. So you give it the Docker file, right? Like the Docker file I just showed a minute ago. And the cluster says, okay, every time I get an update, I'm going to apply this Docker file on top of that, do the build inside the cluster, push it to my internal container registry, and then run the updates using that, right? So that's the experience you have today, but just with your tweaks on top, right? So, you know, with the off cluster, you got the like everything in the middle where you can run CI testing and all that stuff, security scanning. That might be what you're interested in. But if you like what you have today, this is kind of like the lightweight model of that, right? As I mentioned, this is a future feature, right? It's not available right now, probably sometime mid next year, but look out for that to come. Okay, so when I compare these two, off cluster versus on cluster, if you want to do something today, then off cluster is your option, right? The on cluster builds aren't available yet, but production support is coming for on cluster. But for off cluster builds, that's really good for control. You take ownership of your updates. You can run CI pipelines, you can run security scanners. One other benefit I didn't mention before was if you have a lot of clusters, doing the on-cluster option in the future is going to be a little bit more heavyweight because every one of those clusters have to do that build, right? Whereas with off-cluster, you can do the image build once and push it out to all of your clusters that exist. And, for example, run CI/CD testing once, et cetera. So that might be a benefit of off-cluster where you might choose that in the future versus on-cluster as well. For on-cluster, as I mentioned, very easy. You just add, you know, a little bit of config, and then the cluster behaves as it does today, but just with that extra little bit of config. One benefit also of on-cluster is if you're happy today, you don't actually want to change anything about OpenShift, but sometimes something happens and you might need a hot fix build for a month. Well, guess what? On-cluster will make that really easy because you can just say, hey, normally I don't want any changes, but in this case I want to add this extra package or override this package for a month, right? So you can add that in, the cluster will do the right thing, and then when you don't need it anymore, just remove that config and the cluster will go back to behaving like it was before. So that's really nice too. So important notes. Enabling the off-cluster builds with CoreOS layering does mean you take on the responsibility for keeping those builds up to date, right? So like if you do one build one time, switch your cluster to that and then forget about it, your cluster's not going to get OS updates anymore, right? Your version of Hypercube and the host is going to fall behind. So, you know, make sure if you take on that responsibility that you have a plan for keeping it up to date in the future. We don't want you to get out of date, right? Staying up to date is a virtue. And then also for all of this, standard Red Hat support policies do apply. Please stay within your supported configuration so that when you call us and you have a problem, we're not like, oh, that's not supported, sorry. So just keep that in mind. Like you can go back to doing stuff, configuring things a little bit more, but just be aware of that. And as currently, you can only apply these changes after you've installed the system. So currently, you can only do it after the system is already up, so day 2 only. But what I will mention is that we're working on enabling you to do the off-cluster build and then say, hey, I want like a raw disk image or a QCOW or an ISO that has my changes inside of it. This is really good in that kernel driver case, right? Like say I've got a piece of hardware that if you just boot RHEL on without an extra kernel driver installed, it won't even talk, you can't even install to the hard drive. In that case, you need an install image that already has the kernel driver baked in. So in that case, we're adding day 0 custom install media or boot images for those machines. Then also on-cluster build support to GA sometime next year. And then console integration, make it a little easier to click around in the web console and do this rather than running CLI commands.